So we did this question in the last lesson as well, but I would like to quickly go over it again. The question was, draw the locus of points such that modulus z minus 1 minus iota equals 1. Hence, find least possible value of modulus of z. Okay. Acha, from here, we get a point which is 1 comma minus 1. Equate that green part to 0, and then you get 1 minus iota, from where you get the point 1 comma minus 1. From here, we get the radius of 1. So this is actually a circle whose center is 1 comma minus 1 and whose radius is 1. So it's going to be a circle like this. You'll have 2 here and you'll have minus 2 here. Okay. We've drawn the locus, hence find the least possible value of modulus of z. Now, z are infinite points here, which satisfy the given equation, modulus of z minus 1 minus iota is equals to 1. Now, for each and every point on this locus, this condition is true. So now you have to take that particular point that gives you the minimum value of modulus of z. Now remember, what is modulus? Modulus is the distance of a point from the origin. So on this, out of these infinite points on the circle, which point will have the minimum distance from the origin? That's going to be this point here. This distance is the smallest, not this distance. This is definitely bigger than the first one. This is definitely bigger. And I think this would be the biggest distance. So they're asking for the smallest possible value of modulus of z, which is the shortest distance between the origin and one of the points on the circle. So that's that particular point. Now, what you have to do, you have to find right angles in the figure. So I have a right angle here. This is the radius, which is 1. This is the radius, which is, oh, not this right angle, this right angle. This is also 1. So I have a right angle right here. So I'm going to find the hypotenuse. The hypotenuse is 1 square plus 1 square, which is square root of 2. So this entire length here is square root of 2. But we just need this length. Just this length, which is the smallest possible value of modulus of z. This is also the radius, which is 1. So that smallest possible value would be square root of 2 minus 1. And the answer for this question, part B of this question, is square root of 2 minus 1. What if the question was, hence find the maximum possible value of modulus of z? Maximum, or the greatest possible value of modulus of z. Then you would have to consider that point on this circle, which would have the greatest distance from the origin, which would be this point. So we already have this red length, which is square root of 2. All we need to do is add radius to it. So that would be square root of 2 plus radius plus 1. This is the maximum possible value of modulus of z. Any questions from this particular book? Okay. If not, then we move on to the next example. State the locus of points for which modulus of z is less than and equals to 2. And modulus of z minus 0 plus 2 iota modulus is less than equals to 3 minus minus 1 minus iota. Okay. Now the left one is a circle. This is a circle. We don't have any values here inside the modulus of z, so the center is 0, comma 0. Because it's modulus z minus 0 plus 0 iota. So the center is 0, comma 0 and radius is 2. So let's plot this first. So you'll have a circle like this. This will be 2, minus 2, 2, and minus 2. Okay. The radius is 2 and it's less than and equals to 2. That means you have to shade the region inside the circle. That's equals to as well underneath the inequality. That's why I've plotted a solid line. Otherwise, if it were just less than 2, I would have plotted a solid. I mean a dotted line, sorry. So let's take a look at the other condition given to us. This one. Now, when you have modulus on both sides of the equality or inequality, now you're drawing perpendicular bisector. And what points do we have? This one would be equate this to 0. So you get z equals 0 plus 2 iota. So the point is 0, comma 2. And for this one, it becomes z equals minus 1 minus iota. So it's minus 1, comma minus. Let's plot these points first. 0, comma 2 is here. And the other one is minus 1, minus 1, right there. Yes, these are the 2 points. And we're going to sketch the perpendicular bisector of these 2 points. So you're going to use a ruler to give you a better idea. Some midpoint ले लिया, let's say roughly over here, and then make a 90-degree line like this. Okay. Now that is the locus that is needed. Again, since it's an equals to sign underneath the inequality, you're making a solid perpendicular bisector. Otherwise, you would have made a dotted perpendicular bisector. All right, that's done. Now let's look at the inequality. First one is less than equals to 2. So you have to shade the region inside the circle. For the second one, you have to shade that side of the perpendicular bisector, which is with the less than side. So which is with 0, comma 2. So you have to shade that part of the perpendicular bisector, which is here and also inside the circle. So you shade that part of the perpendicular bisector which has the point with the lesser than symbol. And also you have to shade inside the circle. It's going to look like this. All right, moving on. You might be asked to draw locus of points. Yeah, on an Argan diagram. Plot or show z equals 5 cos pi by 3 plus iota sine pi by 3. Now this complex number is in polar form. If it were in rectangular form, let's say if it were z minus 3 iota, then it's pretty straightforward to plot. You have 5 here and you have minus 3 here. So here's the point. 5, comma minus 3. But now it's given in polar form. So in polar form, we know what 5 represents and what it's pi by 3, not pi by 6. Okay. So and we know what theta represents. 5 is the radius which is also called the modulus. And pi by 3 is the angle, which is also called the argument. So let's make a pi by 3 angle. What is pi by 3 in degrees, by the way? It's going to be 180 divided by 3, which is 60. So you have to roughly plot a 60 degrees angle, let's say here. And you're going to say this is pi by 3. And then you have to sketch a 5 centimeter long line. Again, that's also very rough. So you may just mention that this is 5 units. You say 5 here. So it depends on the scale you're using. So it doesn't matter what's the length of that 5. But it could be 5 centimeters on your scale. That also works. But you have to show that this radius or this line is 5 centimeters or 5 units. And the angle is pi by 3. That's how you show that looks. That's how you plot a locus given in polar form or modulus argument form, the other name of polar. Okay. Again, this might be asked like this. On an Argan diagram, show modulus equals 5 and argument equals pi by 3. It means exactly the same thing. Or it might only say that show Argan on an Argan diagram, plot or show locus of points with argument is equals to pi by 6. So now the radius is not mentioned, so you just draw the line, you do not mention its size. So pi by 6 is 180 divided by 6, which is what, 30. So you roughly plot a 30 degrees line and write pi by 6 with it. And we don't know the size of the radius, or we don't know the size of the modulus or the length. So just don't write anything. Okay. And it might say plot on an Argan diagram, plot Argan is greater than equals to pi by 3. So now what you do, you have to shade this region. This line is going to be extended and you shade this region. Like usually you would have 2 lines, so you would know that you have to shade in between the 2 lines. But again, you must be familiar with this term. Argan is greater than equals to pi by 3. Okay, what else? Also, again, you'll see cases like this. Plot sketch or plot on an Argan diagram. Argument means angle. Modulus means radius. So argument is z minus z plus, z minus 2 minus 3 iota equals pi by 3. So how do we plot this? We know the angle pi by 3. What is this? Now you don't start from the origin, unlike the previous question. Origin se nahi start kar dena. Instead, you start from that point. This point is when you equate this entire bracket to 0, you get z equals 2 minus 3 iota. So the point is 2 minus 3. So 2 is here, minus 3 is here. You make that angle from this reference point. This is your new origin. So you may make a small x-axis and y-axis here. And now here you plot pi by 3. So it's going to be something like this. You have to mention pi by 3 here. You may make a small dotted grid at 2 comma minus 3. Because if it's just argument of z equals pi by 3, then you start at origin. You draw that line at the origin. But if it's something else, then you plot that the starting point of the angle at that particular point. Similarly, it could have been less than equals to pi by 3, then you would have shaded this. Similarly, there was a question in past paper which was like this. State on an Argan diagram, state argument of z is less than equals to minus pi by. Okay. So again, now the starting point is origin because there's no other point mentioned with z. So it's origin. So at origin, I have to plot minus pi by 4. Pi is 180. 180 divided by 4 is 90. No, sorry, 45. 45. So it's going to be negative 45 degrees. Negative 45 degree means a clockwise angle. It's going to be like this. So mention minus pi by 4. This is going to be a step 1. Now we have to plot the angle, I mean shade the part which is less than negative 45 degrees. That means negative 50, negative 60, negative 70. That means you're shading this part. Again, in such questions, there's also another line. So you know where to stop. Uski bhi koi condition de de. So we'll see questions like this in the past papers. So it's not like there's an infinite space. तो आपको समझ ही नहीं आया कि अब ये shading यहाँ तक लेके जानी है, कहाँ तक लेके जानी है. There's always another constraint on the question. So we would see that. All right. I think we are ready to start the worksheet. नहीं, एक चीज है. We've studied an identity in log, which was log A upon B is log A minus log B. Log of A minus log B, whatever is the base. We're not talking about the base. Maybe it's 10, maybe it's 2, maybe it's whatever. Okay, so this was the identity. Similarly, this identity is applicable on argument of complex number A upon complex number B. There's a complex number A. Let's say there's A here, and there's another complex number B. Okay. So what is the argument of A divided by B? Instead of actually stating these complex numbers, let's say this is 1 and 3, and let's say this is minus 5 and 4. So they're actually asking you to find argument of 1 plus 3 iota and divided by minus 5 plus 4 iota. Now, a very long method of doing this would be that you rationalize this. You have to rationalize the denominator. You have to multiply and divide this with minus 5, minus 4 iota. Then get another complex number and then find its argument. For example, if you simplify this, let's say you're getting 2 minus 3 iota. And then you find its argument using tan theta is equals to 3 upon 2. और फिर इसके बाद और भी थोड़ा कुछ करना पड़ता था. But that's a very long method. Instead, you will use this property that argument of A divided by argument of B is argument of A, which most likely you would have already found in the previous parts, minus argument of B. Okay, so if you find the argument of A, what is argument of A? This angle from the origin, this angle. And what is going to be argument of B? This angle from the origin. Angle between this line and the positive x-axis. Why am I saying the origin? Sorry. The angle between the line and the positive x-axis. So if you have both these arguments and you subtract them, you have the answer for this. Okay, you will see questions like this in the past papers. होगा क्या कि वो आपसे end में 1 mark के लिए पूछेंगे. Find angle AOB. अब if you're using trigonometry to find angle AOB, then you would be wasting a lot of time, and you will see that the mark given to this part of the question is just 1. तो फिर डेफिनेटली आपने कोई कॉम्प्लेक्स ट्रिग्नोमेट्री नहीं यूज करनी, साइन रूल कोसाइन रूल वगैरह नहीं यूज करना. इंस्टेड यू यूज दिस. वो आर्ग्यूमेंट ऑफ ए ऑलरेडी निकलवा चुके होंगे आपसे, लेट्स से पाई अपॉन 3, और ये दूसरा वाला भी होगा, लेट्स से पाई, let's say it's pi or whatever. Pi upon 3 की जगह हम कर लेते हैं pi upon 2. That is not 90, but let's assume it is. So then all you have to do, you've already found these in the last part, you just subtract these values and that gives you this angle AOB. Okay, so it's a very handy formula. It is part of your syllabus. Keep that in mind while solving questions on argument, on angles. Okay, I think I've already sent you guys the worksheet. Did I? Yeah, dobara bhej. Pretty sure I've already sent it. Okay, I'll take that as a yes. I think I sent it to you Friday's lesson. On Friday. So anyway, let's just take a look at the first question of the worksheet. Okay. The complex number 1 plus iota under root 3 is denoted by U. Let me write that down. U equals 1 plus iota under root 3. Express U in polar form or modulus argument form. So we've already done that. For R, what you have to do, you have to square root 1 and you have to square root not square root. Yeah, you have to square root 1 square plus under root 3 whole square. Remember the formula was if it's A plus iota B, then R is A square plus B square. So what is that? Square root of 4, which is 2. So R is 2. And for theta, the starting formula is tan inverse modulus of and B upon A. So you have to initially ignore the sign. So here the sign is 1 anyway. So theta is, plus anyway, tan inverse under root 3 upon 1. Stick to radians because it says so in the question. Tan set up radians, tan inverse under root 3 is 1 by 3 pi. 60 degrees. Okay, so we have to now properly express it in that format. 2 cos 1 by 3 pi plus iota sine 1 by 3. So that's correct. So next it says, hence or otherwise, find modulus and argument of U square and U cube. How do we find the modulus of U square and U cube? Since we already have U in polar format, our job has been made much easier because we know De Morbi's theorem. Which is, if Z is R cos theta plus iota sine theta, then if it's Z power n, all you have to do is give the same power to R and multiply that power with theta. So keeping this in mind, now for U square, the modulus is going to be R square, 2 square, which is 4. And for U cube, the argument is going to be modulus, not argument, my bad. Modulus of U cube is going to be 2 cube, which is 8. Similarly, argument of U square is going to be 2 times 1 by 3 pi. So 2 by 3 pi, and argument of u cube will be 3 times 1 by 3 pi. So that's just pi. So any questions? Part 2. Show that u is a root of this equation. How do we do that? And state the other root.
इक्वेशन को सॉल्व कर
But उस पे तो आप प्रूफ तो नहीं कर रहे कि u is the root of this equation. उसमें तो you're solving the quadratic equation. देखो दो तरह के क्वेश्चन.
हम उसके फिर ये यू ही आ जाएगा
हम्म
मैम अगर सॉल्व करेंगे तो यू ही आ जाएगा
हाँ के सही रहे हो, बिल्कुल सही कह रहे हो. और दूसरा भी निकल आएगा, साथ ही दूसरा रूट भी निकल आएगा. दैट इज
यस मैम
वन वे ऑफ डूइंग दिस क्वेश्चन. बट पता है क्या होता है कि आपको फुल मार्क्स मिल जाएंगे मे बी, आई एम नॉट श्योर. थोड़ा मार्किंग स्कीम में देखना पड़ेगा कि उन्होंने इस मेथड को भी एक्सेप्ट किया हुआ है. वो कह रहे हैं कि प्रूव करो कि ये जो रूट है ये इसका रूट है. ये क्यों नहीं कह रहे सॉल्व दिस क्वाड्रेटिक इक्वेशन, find the two roots of the quadratic equation. That is not the question. Question is show that this is the root of the question. So actually what they're asking for is, for example, हमारे पास एक quadratic equation है, x square minus 5x minus 6 is equals to 0. एक question है कि इसके roots निकालें. इसके roots क्या आते हैं? Let me just quickly check. 1 minus 5 minus 6. It's 6 and the other one is minus. Okay. एक तो ये question है. एक question है show that 6 is a root of this quadratic equation. Then what do? Show that 6 is a root of the quadratic equation.
लग इन कर देगा
हाँ, exactly. You plug in 6 here. So you have to show that 6 square minus 5 times 6 minus 6 should be equals to 0. When you find that in your calculator, you get 0 is equals to 0. Hence, 6 is a root of the quadratic equation. So this is what they're asking you to do. They're not asking you to solve it and get the values, get the two roots. ठीक है, proof करना है. तो यही हम इधर करें.
ठीक है मैम
ठीक है. दूसरी बात, लेट्स से आपको फुल मार्क्स मिल भी गए, फॉर एग्जांपल आई एम नॉट श्योर, क्योंकि कभी कभी मार्किंग स्कीम इतनी स्ट्रिक्ट होती है कि वो कहते हैं कि नहीं इसके मार्क्स देने ही नहीं है, इस मेथड के मार्क्स देने हैं. तो फिर लेट्स से अगर नहीं है स्ट्रिक्ट मार्क्स मिल गए, लेकिन फिर क्या होता है कि जब डिस्टिंक्शन के लिए वो पेपर्स देख रहे होते हैं ना कि इन दोनों के फुल मार्क्स हैं या इन दोनों के 99% है, इनमें से किसको डिस्टिंक्शन मिलनी चाहिए, फिर उसको मिलेगी जिसने एग्जैक्टली क्वेश्चन की रिक्वायरमेंट को सही समझा है और उसको उसी तरीके से सॉल्व किया. सो दिस रियली मैटर्स. एनीवे, so back to that question, show that u is a root of this. So अब हमें इसमें u substitute कर लेते हैं और देखते हैं कि we should get 0. So I'm going to do that. You may use the polar form or you may not use the polar form. It's up to you. Polar form use कर लें. Since we already have that in polar form, I'm going to use polar form. So we have z square minus 2z plus 4 is equals to 0. Now we have to substitute u in polar form is this. Polar form के बगैर भी हो सकता है by the way. और u square की भी हम polar form निकाल चुके हैं. उसका modulus 4 है और उसका argument 2 pi by 3 है. So I'm going to use that. I already know what z square is. It's 4 times cos 2 pi by 3 minus iota sine 2 pi by 3 minus 2 times z is 2 times फिर से 2 cos pi by 3 माइनस यहाँ मैंने क्यों रखा है, एक्चुअली प्लस iota sine pi by 3. and then there is plus 4 with it. You have to show that this is equals to 0. Is this equals to 0? Let's check. 4 times cos 2 pi by 3 minus 4 times cos pi by 3. I'm writing all the what is that? I'm writing the real parts together. This is the real part, this is the real part, and 4 is real part. I'm entering all of that together in my calculator and checking if I'm getting 0. I should get 0 if I haven't made any mistake along the way. Plus 4. That gives 0. So if you add the real values, you get 0. And now add the iota terms and you should get 0 as well. Let's check that. So 4 times sine 2 by 3 pi minus 2 times sine pi by 3. This should be 0. The root 3 aa raha hai. The root 3 4 sine 2 by 3 pi minus 2 sine pi by 3. Why is that under root 3? That is very strange. Nahi aana chahiye. Let me check. हाँ, क्योंकि इसलिए आ रहा है कि यहाँ पे मैंने placed a bracket here. This inner 2 has to be written with sine pi by 3 as well. So वो bracket में सो रहा था, so it's actually minus 4 sine pi by 3.
मैम वैसे यू ये रेक्टेंगुलर फॉर्म में नहीं लिखा जा सकता है इसके अंदर?
किया जा सकता है, इससे भी exactly यही आएगा. I'll show you. So if you add all the iota terms here and if you add all the real terms here, you get 0 plus 0 iota, which is equals to 0. Hence, u is root of the equation. Hence, u is a root. You can do the same in rectangular form. Let's do that. I'm going to clear this and now do this in rectangular. So in rectangular form, u is, what was that? 1 plus iota under root 3. So 1 plus iota under root 3 square minus 2 times 1 plus iota under root 3 plus 4. You must show that the left hand side is equals to 0. If the left hand side is equals to 0, then u is the root of this quadratic equation. अब इसकी working थोड़ी सी ज़्यादा हो जाती है. So let's do that. 1 plus iota under root 3 times 1 plus iota under root 3. Or use a square plus 2ab plus b square. A square plus 2ab plus b square. Iota under root 3 का square इसके equal होता है. Iota square is minus 1. Under root 3 square is 3. So it's going to be minus 3. Square of that is minus 3. So that's the first term, which is 1 plus 2 under root 3 iota minus 3. Expand the rest of it. This would be minus 2 minus iota 2 under root 3 iota plus 4. So I am getting 0 plus 0 iota here. Everything is cancelling out, equals to 0. Hence u is a root. So both methods work. पोलर फॉर्म ज्यादा हेल्पफुल तब होता है अगर पावर हो जाए क्यूब हो जाए या पावर 4 हो जाए या पावर 5 हो जाए. तो फिर डी मॉर्विस थ्योरम से ज्यादा जल्दी आंसर आता है. स्क्वायरिंग इज नॉट दैट डिफिकल्ट. हम स्क्वायरिंग रेगुलर फॉर्म के भी फॉरन से कर सकते. Okay. Back to the question. Sketch an Argan diagram showing the points representing the complex number iota and u. Let's do that here. Iota to is just iota. Iota to kya point is 0, 1 because it does not have a real part. So for iota, you sketch, you plot 0, 1. Here's iota 0, 1. Call this the imaginary axis. This is real and this is imaginary. Okay, that's one point. And the other point is, what was u? 1 plus under root 3 iota. So 1 is here. And let me quickly see that under root 3 की value क्या होती है. So 1 point something, 1.7. So it's going to be roughly somewhere underneath 2. So let's say according to the scale, this is 2. So let's say कि यहाँ पे कहीं है under root 3, 1.7 something. So here's the other point u. So we plotted u and iota on the complex plane or on the Argan diagram. Sketch an Argan diagram showing the points representing complex number I and u. Shade the region whose points represent every complex number z, satisfying both the inequality. Okay. So what's the first inequality? Z minus iota is less. Let me just send you guys a new link just to conclude this part. I'm going to send a new link. Okay. We have to state these conditions. First one is modulus of z minus I is less than equals to 1. So that there is a circle whose center is 0 plus iota. Because when you equate this part to 0, you get z. Z is equals to 0 plus iota. So the center is 0, 1. And the radius is 1. Let's plot that. Center is 0, 1, radius is 1. So we already have 0, 1 here. So that's the center. And now plot a circle around it whose radius is 1. So it's going to look like this. That's 1, and we'll have minus 1 here. And yes, that is what it looks like. And what else does it say? It says less than 1. So that means you have to shade the region inside the circle. Less than equals to 1. So the circle also has to be a solid circle. Then it says argument of z is greater than equals to the argument of u. Where's the u? U is here outside of the circle, right? This is u. And what is the argument of u? Argument means the angle with the positive x-axis. So this is argument of u. Now you have to shade that part of the circle where the argument of z is greater than this angle. So that's going to be this part. This is what you shade. That is correct. So that is question number 1. And you have to do question number 2 as homework.